Okay, geometry students, appreciate you finding time to get your notes taken care of. Today we're going to be looking at angles inside of our polygons. Actually, we're going to be looking at angles inside and outside. Our title for today is Angles in Polygons. Okay, our objective is the student will learn the properties of interior and exterior angles in polygons and will apply them to solve for unknown values. Okay, so copy your title, copy your objective. As always, press pause anytime you need more time to copy down something that's on the screen, and hit play when you're ready to move forward. All right, so let's get to it. In any polygon, there are interior angles which exist on the inside of the shape and exterior angles which exist on the outside of the shape. Now that may seem like common sense, but go ahead and copy it down anyway. Okay, so you got two terms there. Interior angles, they're on the inside of the shape. Exterior angles, they are on the outside of the shape. Okay. Now, not that I think that you need a picture to go along with that to make it clear to you, but you know, I always give you pictures whenever I can to go along with definitions. Okay, so here is a polygon, a pentagon to be specific, and you can see there are 5 interior angles for our pentagon, which means there are going to be 5 exterior angles to go along with that pentagon as well. Now, if you're wondering what is the deal with all of the dotted and dashed lines and stuff like that, many times with a problem, okay, our shape may not have lines that are actually extending from the polygon so that you can actually see or measure the exterior angles. Okay, so sometimes it is necessary for us to extend one of the sides of the polygon, moving away from the vertex in order to be able to point at the exterior angles. Okay, so in short, when you look at an interior angle and an exterior angle, together they form a linear pair. All right, so let's get down to the measurements of the interior and exterior angles. Okay, a rule that you will absolutely need to have memorized is that the interior angles in any polygon will always sum to the result of a formula. Okay, of course, sum means we're adding them up. Okay, so if you take all of the interior angles from any polygon and add them up, that will be equal to the result of this formula. And the formula is n minus 2, whatever that is, multiplied by 180 degrees. Okay, n in this formula represents the number of sides in the polygon. Okay. So however many sides our polygon has, that is n. You plug that into the formula, and that will tell us how much the all of the angles, when you add them up, how much they will equal. Okay. Really a very simple idea. Okay. So here's an example. What is the sum of the interior angles of a hexagon? Well, all you really need to know in order to work with this formula is, of course, you need to know the formula, but you just need to know how many sides your shape has. So in this case, a hexagon has how many sides? Hopefully we'll remember from back in the day, hexagon is a 6-sided polygon. So for this particular problem, n equals 6. So we'll take our formula, n minus 2 times 180 degrees. We will take n out of the formula and instead plug in a 6. Okay. Remember your order of operations. Please excuse my dear Aunt Sally. We need to work the 6 minus 2 inside of the parentheses, which of course is 4. And then 4 will be multiplied by the 180 degrees. And we get an answer of 720 degrees. That means that the 6 angles inside of this hexagon, when you add them all up, they will equal 720 degrees. Now, it does not mean that each angle is congruent to all the other angles or anything like that. It simply means that the total of the 6 of them, when added together, is 720 degrees. And that will be true for any hexagon, because for any hexagon, n equals 6. Okay. Now we also have a rule that goes along with the exterior angles in a polygon, and this one's pretty simple. It does not require a formula at all. It is simply a fact. The exterior angles in any polygon always sum to the result 360 degrees. That's one of those doesn't seem like it ought to make sense like that, where the three angles in a triangle, they're going to add to 360. The 10 angles on a decagon are going to add to 360, but with the exterior angles, that is always the case, okay? So just to beat a dead horse here, what is the sum of the exterior angles of a hexagon? Well, it does not matter how many sides our hexagon or our shape has, okay? The exterior angles of a polygon always add to 360 degrees in any polygon, okay? What is the sum of the exterior angles of 142gon? Well, once again, when we're talking about the exterior angles, it does not matter how many sides that polygon has. The exterior angles will always add to 360 degrees. Now, obviously, the more sides you get in your polygon, the smaller each of the exterior angles is going to be. Okay, that's how come they're able to always add to 360. Okay, a couple of pretty simple ideas here. So as you can imagine, the only real challenge is going to be the geometry and the math that's surrounding these problems. Okay, so here we have a problem, a quadrilateral. And in our quadrilateral, we have a lot of information about the interior angles going on. In fact, the interior angles all have something to do with the variable x, and to nobody's surprise, we are told to solve for x. Okay, so what we need to start doing here is, once again, just like anything else in geometry, you start asking yourself, well, what do I know about this problem? Okay, well, first off, like we said, all of the x's are involved in the interior angles of this quadrilateral. So then your brain should go, okay, brain, what do we know about the interior angles of a quadrilateral? Well, we know that they follow a formula, that we have this formula, n minus 2 times 180 degrees, and if we solve and simplify this formula, that will tell us what these four angles should add up to equal. Okay, so in this case, what is n? N represents the number of sides in the polygon that you're working with. We have a quadrilateral, so n is 4. Okay, simplifying inside of the parentheses, 4 minus 2 is 2. And 180 is just waiting outside for it to get its opportunity to multiply by. And 2 times 180 is 360 degrees. Now that doesn't mean x is 360 degrees. That means that the four angles in this quadrilateral will add up to equal 360 degrees. Well, that's important information. The challenge in geometry is trying to figure out what equals what. And in this case, these four angles added up equal 360 degrees. So what we need to do is we need to write ourselves a formula. Okay, these four angles, 4x minus 1, whatever that is, x plus 16, whatever that is, 2x, whatever that is, and 3x plus 15, whatever that is. When you add those four values together, the result is 360 degrees. Okay, well, the equation's looking pretty ugly at the moment, but it's not so bad. Let's look for like terms. Our first term over here on the very left-hand side is 4x. Okay, x's are going to want to add and subtract with other x's. So as you can see, we have plenty of other x's. Those x's are going to combine. We also have some constants. Okay, our first constant on the left is -1. He is going to want to add or subtract with other constants. Okay, so if you like the little double underline and single underline idea, that's what I do. Okay, so I'm going to add up all the guys that are underlined once, and I'm going to add them together, and then I'm going to add up all the guys that are underlined twice and put them together. Okay. Well, as far as the x's are concerned, there's 4 of them, and then there's 1 more, and then there's 2 more, and then there's 3 more. 4 plus 1 plus 2 plus 3 is 10. There are going to be 10 x's. And as far as constants, we have a -1 and a +16 and a +15. That is going to be 30. Okay, so suddenly the equation doesn't look so bad anymore. 10x plus 30 equals 360. If you just follow your steps for solving an equation, we should be good to go. Okay, we want those x's by themselves. That plus 30 does not need to be attached to them. So our next step would be to subtract the 30 from both sides to send it over to the right. On the left, the only thing that would be left is the 10x, and on the right, 360 minus 30 is 330. Now we have 10 x's on the left, but of course we don't want 10 of them, we just want 1. So we will divide that 10 to both sides. That will leave just x on the left, which is what we want, and 330 divided by 10 is 33. The problem told us to solve for x. We have x is 33. Okay, as you can imagine, there's a lot of different ways these questions can be asked. Okay, one of the differences being interior angles and exterior angles. Let's look at this one. In a regular polygon, each exterior angle measures 30 degrees. How many sides does this polygon have? Well, let's think about that here for a second. They're saying they have a regular polygon of some kind, and they're saying that in that regular polygon, each exterior angle measures 30 degrees. How many sides should that polygon have? Well, I think the key here is you better know what a regular polygon is. Well, remember that term, regular? Okay, well, what does it mean? Okay. Regular means all of its angles are going to be the same and all of its sides are going to be the same. It's equiangular and it's equilateral. Okay, but in this case, we're not necessarily worried about the sides, we're worried about the angles. So each interior angle is going to measure the same. Well, if each interior angle measures the same, what do you think that's going to do to its exterior angles, like this problem is talking about? If all the interior angles are congruent, then that is going to force all of the exterior angles to be congruent also. Okay, that's important because what do we know about the exterior angles of a polygon? Well, the exterior angles of a polygon are going to add to 360 degrees. Okay, so the however many sides or how many angles there are, they're going to add to 360 degrees. And since we know all the angles are the same measurement, then that 360 degrees must be shared equally with each of the exterior angles. Okay, so what we're going to do is we are going to take that 360 degrees and basically we're going to start subtracting from it. We're going to subtract 30 degrees. We're going to subtract 30 degrees. We're going to subtract 30 degrees. We're going to do that over and over again until we run out of degrees. Well, what is that called when you subtract a certain value over and over and over again? That is a division problem. So basically we're taking 360 degrees, we're going to divide it by the 30 degrees that we know each angle is going to measure, and we're going to find out how many angles can we take away from 360 degrees, 30 degrees at a time. How many angles will that happen with? And we find out that is 12 sides. Okay, so how many sides does the polygon have? It's 12 sides. If they had wanted to know what the name of this shape is, we would have called it a 12-gon. Okay, I'm going to give you one more example just to make sure we get the idea here. How many degrees is each interior angle of a regular pentagon? Okay, well, let's see what we know about that. How many degrees is each interior angle in a regular polygon? Well, once again, what does this vocabulary mean when they say it is a regular polygon? They're saying that it is equilateral and equiangular. Okay, so all of the angles inside of that pentagon are going to be the same measurement. Okay, so we know that the regular polygons have all congruent angles. And what do we know about the interior angles for any polygon? Well, the interior angles for any polygon are going to follow the formula n minus 2 times 180 degrees. Okay. So let's see, what should all of the angles be doing here? Okay, let's plug in this formula and let's figure out what they should add up to. So what's n going to be in this case? We are looking at a regular pentagon. Pentagon, of course, has 5 sides, so we should plug in a 5 for our n. 5 minus 2 times 180 degrees. 5 minus 2 is 3. And 3 times 180 is 540. So the interior angles in a pentagon are going to add to 540 degrees. That's the total of all of them, not for just one. So how can we figure out how much just one angle will be? Well, we've already said that each angle inside of a regular polygon is going to be the same measurement, the same size. So they must equally share that 540 degrees. Okay, so we're going to take that 540 degrees and we're going to say, all right, 540, you got to share that equally with 5 different angles. That's a division problem. 540 divided by 5 is 108 degrees each. Okay. There's literally a bunch of ways they can ask questions like this. Okay, so we're just going to have to understand the concept so that no matter how they word the question, we will be good to go. And at any rate, that is the end of your notes. I appreciate you finding time to tune in and get your notes taken care of. I will see you in class.